As usual, we said x plus 3 here is our first target, equated to 0. Then look for x. This -3 found here, taken in the function to give us a starting point. So we'll have -3 plus 3, so that we get the 2. So the starting point is -3, 2. So we'll have the starting point -3, 2. Here. Let's see if we have the y-intercept. That is f of 0 is equal to 2 minus 0 plus 3, giving us 2 minus √3. This is a positive number, so the graph goes like this. So this is 2 minus √3. So we need to find the y-intercept. So how do you find the x-intercept? So how do you find the x-intercept? We get 2 minus x plus 3 equate to 0. So we have negative x plus 3 is equal to -2. This is possible because we have a negative outside. So when we divide the negative outside, we will have √x plus 3 is equal to +2. So we can now square and square here. So we get x plus 3 is equal to 4. So x is equal to 4 minus 3, which is equal to 1. So this is 1. And the graph ends there. This is 1. Have you seen that it's very easy? Look at question 4. We'll get -x plus 7 equated to 0. Look for x. Divide by -1 here, so that we get x is equal to 7. So that x is equal to 7. Then get the hello.
Sir, the f and then there's that 0 inside. It's ending here, where it ends on 2 minus square root of 3.
Yes.
And then you started again here by equating this thing to 0.
By f of x is equal to 0.
Okay.
So you take 7 in the function again, we'll have -4 minus -7 plus 7, giving us -4, meaning that the starting point is 7, -4. So we have our graph starting at 7, -4. So it's starting here. So what will be the y-intercept? It will be f of 0 is equal to -4 minus root of -0 plus 7, but 0 is just 0. So we'll get √7. Remember, √7 is less than 3, but there's negative, so that number is small. That number is -4 minus √7. So you can see that there are no x-intercepts here. So the graph starts from there, coming this side. So how do you know there are no x-intercepts? You can try to equate it to 0. We'll get negative x plus 7 is equal to 4. Divide -1, divide -1, we'll get x plus 7 is equal to -4. And we said, whenever you see this thing, just know that this does not exist anywhere in mathematics. So the solving of x-intercepts is called radical equations. So maybe just two more examples on the equations now.
Sir, bring back red other board, please.
Excuse me, sir.
Mhm. You're excused.
I have a question for the third example. Isn't the graph supposed to be curved upwards from the ones that you showed us last time for the general shapes of the graphs?
Supposed to be curved downwards. It's only curved upwards if what is negative is x inside one and not the outside of the root.
Okay.
Yes.
Okay, thank you.
Fine. So
Sir,
this was,
bring
yes.
back the other board. Yeah. So you're a bit fast. Why?
Just, just get the screenshots of these guys. Don't call me. So as we move a bit fast.
Sir, I just didn't get what you said, explaining why the graph is going downwards.
Because the starting point is higher than the y-intercept. The starting point is 7, -4. The y-intercept comes out to be 0, -4 minus √7. So it's down.
Okay. Okay.
Okay. Okay. So now we can move. This was example 4, example 5. Just do my screenshots. Yeah. Solve for x. A root of 1 plus 2 root x is equal to √1 plus x. Solve for x. B root of x plus 4 is equal to -3. So let's do A. Whenever we have roots, or even just one root, the first thing should be this is where I'll do my first thing. The first thing should be squaring. So I have to get rid of the square root. So we'll have 1 plus 2 root x is equal to 1 plus x. Then now, take everything which is not under the root, take it to the side. Yes, Linda. It's determined by the family. So we take this one the other side, we'll have 2 root x is equal to 1 plus x minus 1. So we understand that the ones there will go, and we'll have 2 root x is equal to x. We still have a root here. We can choose to divide by 2, so that the root remains alone. And then follow it up, square, but we can't just square the root, we also have to square the other side. So now we have x is equal to x squared over 4. Then now we cross multiply again. 4x is equal to x squared. It has become a quadratic, so we need to be careful. Minus 4x is equal to 0. Factor out x, we remain with x minus 4 is 0. So x is 0 or x minus 4 is 0. This is x is equal to 4. So we have this. We also have this. Very, very important to go back and test. So testing, when x is 0, you have 1 plus 2, 0. The other side, when x is 0, you have 1 plus 0. And these are equal. Root 1 is root 1. So far x is 0 is the solution. What about 4? 1 plus 2 root 4. This is the same as 1 plus 2 by 2 because root 4 is 2, which is the root of 1 plus 4, which is root 5. The right hand side, the root of 1 plus 4 is root 5. So the two are equal. So x is also 4. These are our solutions. So you keep on squaring until there's no more square. Until there's no more square root, yes?
Sir, can you repeat that we squared the next square root? What happened?
After we squared there,
The second square root.
after you square here, then you have x is equal to x squared over 4, which is a quadratic. And since there's no constant, the easiest way of solving it is just factoring out x, so to remain with x minus 4 inside, and then equate each piece to 0. Then test.
Sir, can you please repeat on the explanation on how you're testing?
The testing, you just substitute each value where there is x for both sides, and the responses must be equal.
So what do you mean the
Sir,
responses
sorry.
must be equal?
The answer you get on the right should be equal to the answer you get on the left. The right and left of the equal sign.
Sir, isn't it that what you're producing from the left-hand side, that is producing the thing on the right-hand side?
Is what is it?
Producing the thing that is on the right-hand side.
No. They both have x. So we take the x in both sides.
I don't understand.
If it was y is equal to root 1 plus x, we can say this produces y. If what you're having in your hands is x. But now we have x from both sides. We have x from both sides. So which one will produce the other? None. So if the equation is true, the two must be equal.
All right, thank you, sir, I understand.
Good. What about
Sir.
D? Yes.
Sir, I have a question on why we're testing. What's the reason?
Just want to verify that the values of x found here are correct and that they both satisfy the equation. It's possible sometimes you solve like this and you find that some values of x do not satisfy the equation. Especially if you insist in equations like B, you start squaring. It's very cardinal that you should test because there will be no solution there. So that
Then
for
how do
B,
you know? Therefore,
how do you know that?
after you test, like what are you supposed to get to be sure after your testing?
If the left hand side gives us root 5, the right hand side must also give us root 5. Sometimes you find here you have root 7, here you have 0. So root 7 is not equal to 0. So you cancel that solution. But when they are equal, you take both.
Sir,
Hello?
yes, sir. I mean, as in, so mean, what if all the values of x are not are not solution set, are not part of the solution set? So you can write no solution for that certain equation.
You write that the solution set is empty. Like for question B.
Oh,
Yes.
but sir, why is it empty, that one? Solution B.
But we just said that the root cannot be equal to a negative number. Remember? In the other
Oh, yes.
before we cut, we said the positive root cannot be equal to a negative number.
Right, yeah.
Catherine,
So
after you test, you conclude that the numbers you use to test are the solutions, x values, not what you get. No, these are just telling us that our solutions are correct.
Sir, what do you mean by positive roots?
Positive root, we mean there's no negative outside the root. There's no negative outside the root.
Oh, okay. So if it's negative like that and equal to a negative number, it can be solved.
You can solve because we divide the negatives.
Oh, okay.
So that's the situation. Have you seen that when we reached here, we said that this cannot be done, is it?
Yes, sir.
So it's what is helping us to say B, no solution. And in an exam, you find such questions there. Then you try, because if you square, automatically you get a solution. Until you test, that's when you know that there's no solution here. And there was that question I remember in the quiz. It should be a quiz. It should be a quiz if not a test, where people kept on squaring and then they are forgetting to test. And the marking key was saying, if they give a solution where there's no solution, give 0. So what I did was, because most of you squared. So I ignored that part and gave a mark for finding the value of x that you would obtain if you square there. So I gave, it was out of 4. So I was giving 2 marks for getting that value. And for those who tested, I was giving another 2 marks for saying that there's no solution. It was supposed to be 0. Those papers that you're having there, and you have such a thing, it was supposed to be 0. So in an exam, don't even try. If you square here and forget to test, 0. Just say empty. Yes.
sir, on B part, can't you solve it then at the end of solving after finding the x, when you test it and you say the solution is empty? Is it okay?
Yeah.
Like there's no solution.
If you want to insist, you can. But just know that there's no time. There's no time allocated in the exam for you to solve. So I was just solving that. You're using your spare time if you are too fast.
All right, sir.
So now after we've tested, and then let's say whatever you tested is not the same, like the sides are not equal. Do you have to go and resolve, or you can, what's the conclusion then?
You conclude that there's no solution. The solution is empty.
Oh, there's nothing like you made the mistake.
No, it's possible that for someone you are sure, it's possible that the solution has not. Because look, let's solve this and see what will happen. You square we have x plus 4 is equal to -3. We square here, we square there. We'll get x plus 4 is equal to 9. And then what will happen? We'll have x is equal to 9 minus 4, which is equal to 5. So x is equal to 5. So far, this is our solution, is it? Then you go and test. You have 5 plus 4 is equal to √9, which is equal to 3. But this number is not equal to -3. So the solution is empty.
So, sir, what if you solve? Can you give a mark?
You get the same marks as the person who has mentioned that the solution set is empty because the root cannot be equal to a negative number.
So, when presenting the answers of the first question we had, the one that has 0 and where x is equal to 0 and x is equal to 4. So you present them 0, 4, whereby you use those symbols that mean included or not included.
0,
0,4. Now you use the included symbol or the other one.
This is a set 0 and 4. They are not intervals.
No.
So, sir, on the very same one, like how he has asked this, you can't use the very same one, say they're included or not included, applies to question B, like where 5 isn't the solution, like
unless you do this,
question.
unless you do this. They are not intervals.
Oh, okay. How about B?
B?
Yes, sir.
B, how do you show the interval of an empty set? You do this.
Okay, sir.
The thing is, look, you only have intervals if there is greater or equal to. If there is greater, there is less, or there is less or equal to. These are the only times when you're going to have intervals.
Okay, sir.
Sir.
Yes.
Sorry, we are late. This is when I've joined in. I was asking if at all you can slide the previous slides. I just screenshot then I can understand.
All the best.
Okay.
Another one.
Yes.
Yeah.
Hello.
You've only done
Isn't
3
it-
and 5.
Yeah, we've
Isn't it
only
that
done
the
3
number?
and 5.
Okay.
I have
Thank you,
a
sir.
question, sir.
Please, you can ask. Is that a question?
Or if we square 9, isn't it that we're going to get positive or -3?
Yeah, it's true.
Yeah, so why isn't -3 equal to -3?
Why isn't the 3 equal to -3?
When we square the 9, don't we get positive or -3?
When you square root 9?
Yeah, we get positive and negative.
You get 3.
Oh, okay.
It's only that -3, if we square it, it can give us 9. 3, if we square, it can give us 9. So when do we have such a thing? When you are asked to find the values of x that when we square, they can give you 9. That's when you give 2 of them. Do you get the difference?
I get. Thank you.
Good. Okay. That goes done. But expect questions like the square root of x squared minus 1 is equal to the square root of 4 minus x. Expect these and just be assured that there's nothing that has changed apart from squaring, get there and then put things together, solve, then test. So normally
this is the first type or the fourth type.
No, this is just a mixed type of equations. We are not dealing with equations. So we are done. There are only 4 types. Now we have gone to equations which are mixed type of setups.
Sir, sorry to take you back. That one, the root of x squared minus 1. Assuming they tell you to graph that side. So since we're going to find 2 values of x, then upon finding the value of y, you also find 2 values of y, the y-intercept, they must be 2 as well.
If you want to sketch, you have introduced another thing.
Yes.
You have introduced.
It is a question that because I saw it somewhere like a root of x squared minus 9.
That's what I'm saying, that you have
Then
introduced another animal. F of x is equal to x squared minus 1. If you have to sketch this, what is the domain? You say this must be greater or equal to 0.
Positive 1.
Meaning that we have x minus 1, x plus 1 greater or equal to 0. So get the critical values. X is equal to 1, x is equal to negative 1. So we have negative 1, we have 1. So we have 0, the middle number, 2, and negative 2. Then get x minus 1, get x plus 1, get x minus 1 multiplied by x plus 1. Then test. So we have very, very few minutes. Hope I managed to save this thing. I'll manage 8. So you take negative 2 here to be negative, negative to give us positive 0, negative, positive, negative 2, positive, positive, positive. We want where it is greater or equal to 0, meaning we want the positives. So the solution set, which is our domain, is going to be negative infinite all the way up to negative 1 included, union, positive 1 up to infinite. Then you sketch.
Sir?
Hello?
Just explain what you are from saying. From the top.
From the.
Sir, yeah, I'm confused now.
But why confused?
Sir, you've just introduced this sign on a one.
No, how do you get the domain of the thing which is inside the root? Functions, type 2. Find the domain. You say whatever is inside the root must be greater or equal to 0 because the root cannot handle a negative number.
Sir,
what is root 0? What is root 0?
It's 0.
What is root negative 4?
Undefined.
It's not a real number, is it? So if you give me an x, I will make sure that it must be greater or equal to 0. Because if you ask me to give you root 4, I'll give you 2. Is it? This is why we are saying the domain of any root must make sure that whatever is in the root must be greater or equal to 0. And what did we say when it is a product? When you have a product greater or equal to 0, what do you use? You use a table to find the intervals in which that thing is going to be satisfied.
Sir, I'm still confused.
So where are you confused exactly?
Why the square root of x squared minus 1? Like, why the inequality is being introduced? So this can't be solved without the inequality?
The question is sketch and not an equation. Equations have equal signs, is it?
Yes,
Now,
sir.
see the difference? This is an equation. There are equal signs and the like. This one is just saying sketch. F of x is equal to the root of x squared minus 1. So now you're beginning to sketch. So how do I sketch? I must know my domain. So how do you know the domain? Whatever is inside the root must get or equal to 0. So which intervals starting from 1 to the right and from -1 to the left? These intervals.
So
Mm-hmm.
the reason why you are using greater or equal to here, like in those other questions, we were not using this greater or equal to. It was because it didn't have a power of 2, right?
It was because they were just linear.
Okay. Then that
Where
one
you-
is linear. Oh, that
Yeah,
one is
because-
quadratic.
Yeah, because even this, the first thing we are saying is that this guy must get equal to 0. That's why x was get equal to -3. And if you look at the graph, it's starting from -3 going to the right, is it?
Yes.
Okay, good. So if that is the case, then yeah, okay. So now let's quickly do the sketch. We only have 4 minutes. So if you pick 1 and take in the function, you get f of 1, root of 1 minus 1, which is 0. So we'll get a point there. So you get a point here. Then no, you can't get a domain of what is in the root by equating to 0. What is in the root must be greater or equal to 0 and not equal to 0. Just when you take -1, you get -1 and have it squared minus 1, you still get 1 minus 1, which is 0. Another one there. So if you get 2, we'll get root 4 minus 1, which is root 3, which is up there, meaning that this guy is going to go this way. And if we get -3, we'll have it, if we get -2, we'll have it squared, then -1, which will be 4 minus 1, which is 3. So it will go somewhere there. So it will go this way. So those are that's how our graph is going to look like. It will be mixed, jumbled like.
Okay, thank you, sir, for this one.
All right. Okay, so we end of this and end of radicals. So this is exactly 13:20. Okay. 40 minutes we still have. I don't know if the weight is you are capturing.
Sir.
Please talk. We only have a minute plus seconds.
So how do I access these recorded classes?
We send them in the group.
So it's done for today's class.
No, we still have 40 minutes. This is 2 hours class.
Oh, all right.
We are coming to do polynomials.
All right, sir.
Okay, sir, before
So
you
what
start
time are we
polynomials,
meeting again?
Just after, so you log out, log back.
So how did you graph the points? Use -2 there.
Yes, no, use -2. Remember that any value that you take in that root, it has to be squared because x is squared. Okay.
Please see the previous page.
Hello?
The
So
previous
are we not
page.
-2 comma the root of 3?
-2 comma?
The root of 3.
Yeah, it's here. The root of 3 is positive, is it? So -2 is x, so x comma y. The previous page is here.
It's about that one.
Okay, so let's log out and come back quickly. We are starting polynomials.